To introduce myself, hello again, my name is Christian Boxley, and welcome to the next iteration of the monthly statistical seminar series. In this seminar, we are going to discuss data visualization and some of the basics of Tableau. We're going to demonstrate these basics using COVID-19 surveillance data that we've collected as part of a contract with the CDC. So here's a rough outline of our agenda for today. First, I'll introduce myself, then we'll talk through some of the goals of the presentation. Next, we'll discuss what data visualization is through some examples. Then we'll quickly touch on how cognitive science plays a role in data visualization. After that, we'll talk through how to approach data visualization. And last, we'll give a live demo of Tableau, show you all some resources which are plentiful across the web, and answer any questions that pop up in the Q&A. Which leads me to two reminders. First, feel free to drop questions into the Q&A as they pop up. I'll get to them at the end. I'm hoping to save 5 to 10 minutes for those questions. And second, this seminar is being recorded. So with that being said, let's jump in. So first, introduction. So again, my name is Christian Boxley. I graduated from Georgetown University majoring in biology of global health. In August of 2018, I started working at MedStar Health, the National Center for Human Factors in Healthcare. And my current title is Senior Research Associate, and I'm also on the center's data science team. In my free time, I play Ultimate Frisbee, and fun fact, I have appeared on ESPN SportsCenter's Top 10 Plays twice for 2 different sports. And as far as I know, I'm the only person to have achieved this very random specific feat. But if you all know of anyone else who has, feel free to forward them my contact info. Maybe we can start a club or something like that. So next, what are the goals of this presentation? Let's start with what this seminar isn't going to do. So if this is your first introduction to visualization, after an hour, I cannot promise you that you'll be a guru. And I also cannot promise you that you'll be able to make beautiful visualizations like the one you see on the right. Secondly, there are people who make careers out of data visualization who've researched this full time. And that's to say that I'm not a complete expert, but I do have a lot of experience thinking about and creating visualizations that I think will be very helpful for today's talk. So now that we know what this presentation isn't going to do, let's figure out what this presentation is going to do, which is a good question. So after this presentation, I hope you all have the building blocks and be on your way to making and thinking about visualizations, to start asking good questions about data viz and thinking critically about data viz. So next, we're going to talk about what is data visualization. And I think the best way to discuss what data visualization is to provide examples. With that, what do you all think when you hear data visualization? I know this is a rhetorical question, but I'll still give you a couple of seconds to think about it. So when I hear data visualization, I think of an Excel spreadsheet that's open, similar to the one that's on the screen. You have some basic data, you click a few buttons, and boom, you have a bar chart with heights of 5 different trees, like in this example. But data visualization really is much more than that. So starting simple, here are some simple tallies, which are actually a form of visualization. I bet that you could see what favorite pet was chosen most often without even looking at the numbers on the right, just by simply glancing at the tally marks. Data visualization is also in nature. So many trees that live in temperate zones produce growth rings each year, with the newest growth ring adjacent to the bark. An image like this, you can quickly glance and see around what age a tree is, along with what might have happened to that tree. Had it been in a fire? Had it been disturbed in any other way? So these ring patterns reflect the age and the climate conditions in which a tree grew up in. Data visualization is also in everyday things you probably don't even think about twice. It's so second nature that you could probably infer what kind of road this car is driving without even thinking about it. You can see that it's going 55 miles per hour, so it's pretty easy to infer that this car is driving on a highway with about a quarter tank of gas and a lot of miles that this car has taken on. Data visualization is in all kinds of current events. So between elections and COVID-19, you all are probably very familiar with the choropleth map that's seen here, and probably or potentially very tired of them. So here we have a snapshot of COVID-19 cases in the United States. This is a snapshot taken at December 7th of 2020 by the New York Times. And we can see here that COVID-19 is a large problem in the entire country, but particularly it's a large problem in the Midwest. So with those examples of data visualization in Pocket, let's start to talk about how cognitive science plays a part in data visualization. In other words, to understand why visualization is so important, we have to understand some basic things about human perception. So I know you're probably staring at the screen, but take 10 seconds to look away from your screen and appreciate the richness of your visual world. The colors, the space, the details, the depth. And hopefully in that time, you were able to see how central vision is and how we take in information about the world and how we operate in the world. Humans are visually driven creatures. So think about this example, the demands of driving a car. So you're navigating the road, you're looking at people around you, obstacles on the road, you're constantly monitoring and making judgments about signs and symbols. You have your dashboard, you have interactive displays inside your car. Again, there are signs on the road. So all this is to say that vision is intertwined with senses of space and objects and action, and it really is key in how we perceive the world. Here we have a busy street, and people are able to navigate a street as busy as this because of vision. So all this is to say is that the brain can process a lot of information at once. Think about a TV show that you might have watched. In your head, just by looking visually at that TV screen, you're creating a narrative about people, events, their mental states, etc. Now think about reading a book. As you're reading, you're rapidly processing visual symbols and text to do the exact same thing. Next, let's get into the strengths of human vision. So we can see here that the brain can extrapolate from very limited information. It can spot outliers, gaps, clusters, trends, colors, and shapes. And vision really does take a holistic view at the image. So if we take a look at these 8 examples from left to right, the first example is emergence. So just blots of ink can create a visual picture. In the second picture, multi-stability, we can see 3D shapes on a flat surface because of our ability to perceive angles and what should be 3D. We can see backgrounds and foregrounds, and we can see flip between the two. So we have faces that are making up the white part, the background of the vase. But if we flip our perception, all of a sudden we have a vase in the background of 2 faces. Next, we can see shapes that aren't really there. So in the triangle, we have 3 Pac-Men, but there's not really a triangle there, but our vision is able to perceive that those 3 Pac-Men make up that triangle. And the same with this spiky ball, where a ball isn't even present, or this snake, or if you're Scottish, a Loch Ness Monster that might be on the surface that we're able to perceive, but is really just 3 kind of random shapes on the screen. To the right of that, we have invariance, where we're able to perceive 3D structures of shapes as it flips around and reorients itself. We can see that 3D shape even with dashed lines, which leads us to the next example of closure, where dashed lines can create shapes that are really, if you just look at it, just dashed lines. And onwards, and the same principles kind of apply as we go through similarity, proximity, and continuity. So basically, we're able to fill in the blanks, fill in and extrapolate from limited information. All that is to say that there are weaknesses of human vision. I'm sure everyone here has seen their fair share of optical illusions. In this pretty famous one, I still don't really believe it by looking at it, but all the balls on the screen are the same color. It's an optical illusion of the lines that crisscross between the balls that make us perceive the balls being different colors. Continuing with the weaknesses of human vision, vision can easily be overloaded with noise. So think of yourself on the busy intersection in Times Square. It's almost impossible to take in all the visual cues that are in front of you, just because there's so much information. On the other hand, when we're used to a visual cue, it can sometimes fade away where that cue shouldn't be ignored. For example, I can update my computer and I'll have this big update warning that I can easily ignore for an hour, and I can continue to do work up until that warning forces me to restart my computer. I can ignore that visual stimuli and continue focusing on what I am doing. But that can lead to problems when we think of the EHR or in clinical spaces where we have a visually overloaded EHR that makes it hard to even order something as simple as Tylenol, or maybe visual warnings that are easy to overlook from doctor's point of view because there's so many different warnings, or maybe a warning appears too often where that warning starts to be ignored, and then a week later that warning is actually something that's serious and should be brought up to the attention of the doctor, but the doctor is so used to that signal that they no longer pay attention. So all this is to say that when creating visualizations, it's important to understand the weaknesses and strengths of human vision. So you can use humans' perception and the benefits of that, so the high bandwidth, the holistic view that vision that we're able to perceive, and pattern recognition. We can do those things to create the best visualizations possible by taking the strengths of human vision and limiting the weaknesses of human vision. We can design accurate representations of data to reduce the impact of perceptual biases and change blindness and visual noise. So we can do all these things to support human activities like exploration of a big data set, insight into big data sets, and then communication of those insights. So next, we're going to get into approaching visualization. So here we have a public data source of safety events related to medical devices. And just by looking at this table, it is almost impossible to find insights from this data using this table. But with one simple visualization, we can create a lot of insights in that table that was previously almost impossible to get information from. With one simple visualization, we can create a bunch of insights. So here we can see that the number of reports is increasing year over year. And we can see dips around Thanksgiving and right before the start of the new year in reporting. And for the most recent 2 years, it looks like a lot of events get reported at the start of the year, maybe because medical devices are more difficult to use after time away from the office, or time away during the holidays, or maybe because there is a lot of reporting that gets put off at the end of the year and people are scrambling to report all those things at the start of the year. We don't know exactly the reason why, but we do have insights into that data that was previously almost impossible to get insights from. So this is to say that one approach to visualizing data is to explore the data that you have in front of you. So with this exploration, your audience can vary widely. It can be somebody super familiar with the data. It can be someone that is just looking at data for the first time. So your audience varies. There's also a high level of interaction. You want to be able to filter certain things and highlight certain things. And all this is used to gain insights. And this visualization structure can evolve over time to get even more complex insights out of your data. So again, from this picture, we see that more complex visualizations can allow dozens of insights. So specifically talking about this image, we have data on what providers are making calls on, when those calls are happening, where the calls are happening, and how long those calls last. So you can do a lot with just those 4 columns of data, those 4 fields. For example, you can see that in inpatient settings, most of these video visits are happening in ICUs and are being facilitated by nurses. There are also 2 levels of exploration. One in the dashboard itself, where you're exploring your data. And then second, you can explore the dashboard and iterate on your dashboard to create better dashboards like I alluded to. Second, visualizations can drive operational decisions. So usually here we have a known audience. Ideally, this is an audience where you can communicate and tune your visualization to best fit the end user. So lots of communication between developers and users are ideal. There's also varying levels of interaction depending on who the end user is. If it's an end user that's kind of strapped for time, think of a CEO or somebody in a high leadership position. They might not have the time to create all these different filters and highlight certain things and really dive deep into the data. They want something that's static that they can quickly look at, glean information from, and drive their operational decisions. On the other hand, if you have a manager that's just as deep in the data as you are as a developer, there can be large levels of interaction where the manager is getting just as much of a picture of the data as you are as the developer. So here is an example of a dashboard that was updated every morning, and the structure of this visualization stayed consistent over 5 months. And we can see from these data that the number of visits are increasing over time. And we can see the number of patients who are leaving this call line without being seen by a provider. We can see when the calls are happening. And all these different insights support awareness and give associated information so that we know, for example, what time during the day do we need to have the call line most staffed, or how satisfied are patients that are calling this line from the star rating in the top right, how long calls are lasting. All these things can impact operations. And the third and last approach to visualization is communicating your insights. So typically here you have a general audience, probably on the larger side. And here, if you're just trying to communicate insights, you want low levels of interaction. You want your information to be highly glanceable and intuitive. So in this example here, we have the United States and 4 Scandinavian countries, and the number of COVID deaths per million over a 7-day rolling average. And we can see that Sweden did something drastically wrong in November, where their death rates crept up to and above the United States death rate by the beginning of December, while the 3 other Scandinavian countries that can be seen here all stayed relatively low compared to the other 2 countries. So this type of approach can parallel grant and publication writing, where you don't know who will be reviewing your submission, who will be reviewing your paper, but you want that information, those insights that you're trying to communicate, to be as easy to communicate as possible, as simple as possible. So, questions to ask yourself as you're developing visualizations. They can start with, what are you trying to highlight? And how does this visualization fit in the bigger picture that I'm trying to communicate? It can be the strengths and weaknesses of a chart or a presentation and the data. That's to say that there's no perfect visualization. There's always going to be a visualization that makes things harder to see, that doesn't have the complete context, that makes certain things too visible or too highlighted. So all I was to say is, what does the visualization show and what does it hide? And beneath the visualization, it's important to think about the data itself. So where does the data come from? What's missing from the data? How reliable is it? This can be everything from what the data doesn't have to what values are null. So if you have a column that's 50% null, you might have to ask yourself, is that a column of data that you can actually trust? And the last part is thinking about who your audience is, or who the audience for that visualization is, and what the purpose of that visualization is. So all these things can help you, as a beginner to data visualization, start to think about visualizations critically and creatively. So next, we're going to get into a walkthrough of Tableau. But first, just to start with some quick intro bullets. So what is Tableau? If you've never heard of it, it's an American interactive data visualization software company, and it was founded on the campus of Stanford University in 2003. So it's a relatively new company, and Tableau is the name of the company and the product. If you think about comparing it to something like Microsoft Excel, Microsoft is the company that owns or develops Excel, and Excel is the product. But in this case, Tableau is both the company and the product. And in 2019, it was acquired by Salesforce for an astronomically large number, which might speak to how valuable the software is to people around the country and around the world, really. And it's used to query relational databases, spreadsheets, cloud databases, and generate visualizations. So if you think of your data as being a library, Tableau is the patron going to that library, picking out the books or the specific data points that it wants, and then creating visualizations from those books, and much more. So with that being said, I will get into a live demo of Tableau. So let me go ahead and share my screen here once more. Okay, so to quickly talk through the data that we're going to be looking at within the dashboard to protect the health information within that data, I just have a quick summary of the data here without looking at the actual data points. So you can see here we have about 14,000 rows of data with 46 different columns or fields. And those column names are everything from the names of participants in this data set to identifiers, to the status of the participant. Is that participant active in the study? A bunch of contact information like emails and phone numbers and addresses, the county, state, and zip code where those participants live, and then other key demographic information like sex, date of birth, and ethnicity and race. So with that being said, let's go into Tableau. So here we have the main kind of interface when you open up Tableau. And to orient everyone, we have our columns that we talked through in that text file on the left here. So things like address, date of birth, ethnicity, and then we have measures. So for example, if you think back to that tree example, where we had the trees and a bar graph in that simple Excel example. We had the heights of those trees, and those heights would be a measure where the tree, the breed of that tree, would be a dimension. So I think it would be best to look at an example of what Tableau can do, and then we can work our way from beginning to something that looks a little bit like what we're seeing right now. So Tableau can create these very powerful dashboards. So here we have the active participants in that COVID surveillance study that I mentioned at the beginning of this talk. We have a dashboard of the active participants, and we can get all kinds of insights. So we see that we've sent 14,000 invites to participants, and we can hover over here and see the statuses of those participants. You can see that about 84% of those invites were sent to people who are now active in the study. We can see we have about 12,000 active participants, and we can see a running sum of when those participants enrolled in the study. We can see how many new daily active participants we're getting with each of these bars, along with a 7-day moving average of new participants. We can see where those participants are located. So their county here, and then we can see that map kind of blown out and see what states are represented in our study. So you can see here about 45 states out of 50 are represented. And then we can get breakdowns of the demographics of the participants we have above. So race or ethnicity breakdowns by age, we have a histogram here, and then breakdowns by sex. And furthermore, Tableau is very powerful because you can create filters within this dashboard to create even more complex or create insights that are a little bit beneath the surface. So if we wanted to only look at our female participants, we could click the bar here, and you can see the dashboard update in real time to reflect the new filter we have on, which is just our female participants. So you can see 8,100 active participants. The same number can be seen here. The number of invites sent to participants that led to the 8,100 active participants, where they're located, the age demographics, all this updated in real time just by clicking on a quick filter. So let's filter back out, and let's look at our Black or African American participants. And we can see here, things look a little different, only about 1,000 active participants. And we can see that our map updated to show us that most of our Black or African American participants are in Prince George's County, as opposed to the overall population, where participation is centered around DC and Montgomery County. So with what we know Tableau can do, let's do a quick demo of how do we get, for example, a corpus map like this, and how do we get a bar graph like this. So let's go back to our blank sheet. And it really is easy to use this software. I would say the software is easy to pick up. You can pick it up, drag and drop. There's no hard coding or any real technical skills needed. It's similar to Excel, where you can pick up Excel and start playing around with it. But I'd say it's also difficult to master. There's a lot that this software can do. And as you put in hours and time into, there's that update that I mentioned earlier. As you put in time into the software, you start to pick up on things that you didn't know the software could do. So easy to pick up, difficult to master. With that being said, let's make that first bar chart of sex in our participation. So we would go to our dimensions, and you can see we have our column sex at birth. We would drag this pill over to our rows, and you can see our female, male, and then our participants who haven't filled out their sex at birth. And then we will go down to our measures, and we want the number of records or the number of participants for each sex tier. So we would drag this over to columns, and Tableau automatically knows or guesses that a bar chart might be the best way to create this visualization. So we can see something very similar to what we had in the previous dashboard. And to make things easier, we can also drag this number of records, create a duplicate version and put it on label. And then we'll have our bars labeled with the number of participants for each sex. And a lot can be done with this simple visualization. We can sort it so that our top sex is on the top. So we have 8,800 females. So we have it sorted. So it goes from the 8,800 females to the 4,000 males to the 1,200 participants who haven't filled out their sex at birth. We can also flip the columns and rows just to get another view of the data. And if we wanted to, we could look at all different types of dimensions here. So if we wanted to look at, let's say, race, we could drag that on here and again sort and see the races for our participants. We could do the same with zip code. So you could see what zip codes are most represented. And it looks like 20016 is the most represented zip code. So it really is a drag and drop software that's easy to use, easy to pick up, and yeah, you can spend hours kind of dragging and dropping and playing around and figuring out what kind of workflows work best for you. So let's go back to our sex at birth, and then let's create a second visualization that is similar to that core pleth map that we had at the top right of our previous dashboard. So that map was broken out by county. So we'll go to our dimensions again and scroll up to county. And we're going to drag this to detail. And you can see Tableau knows that this county field is a geographically oriented field. So we drag county to detail and it automatically creates a map where it has latitude and longitude generated for us. So we want to know how many participants are in each county. So we go back to number of records and we put that on color to create that heat map that we had earlier. And let's go ahead and zoom in to Maryland, DC, and Virginia, where our participation is centered. And you can see that some of these gaps need to be filled in. And there's this warning down here that there are some unknown values or unknown counties that Tableau is trying to figure out where those counties belong. So we'll go ahead and click this warning and edit the locations. And we can see that, yes, we have county, our county field here. And there are a bunch of these counties where Tableau doesn't know where they're supposed to go on the map. But we have an easy fix because we have a state field in our dimensions. We can tell Tableau, hey, Tableau, go into the state field, map the county to each state. And then it automatically fills in the rest of this map with our participation. So again, very easy to use, drag and drop. And if we head back to our PowerPoint, Give it 1 second to load. There we go. And we'll go back to the slide we were on. So that was just a quick walkthrough of Tableau. And I think I have some tips and tricks before we get into the resources that are available. And these tips and tricks can relate to any software you're using, any visualization you're creating. It can apply to something that you're drawing on a piece of paper, drawing on a whiteboard. It can apply to what you make in Tableau, what you make in Excel, what you make in any software, really. But the most important part is to speak your user's language and that the details matter. It doesn't matter if you think a visualization looks good or is important or is easy to understand if your end users or your audience think the opposite. So it's your end users that matter, and you should develop a dashboard that meets their needs. And if you're able to, get feedback early and often. So if you're creating a visualization that's going to be driving operational decisions, get feedback from the people who are making those decisions, figure out what information they need, how they want it to be presented, develop and test something that you've made with those end users before you get too deep into the development of that visualization. So get feedback early and often. If you're making something for a paper or a proposal, ask people who aren't as deep in the subject matter as you what they think of a visualization. If it's easily glanceable, if it's intuitive, get that feedback often and create this kind of loop where you're constantly getting feedback and developing until you're happy with the end product. And ask those guiding questions. So if you're exploring something, exploring a data set and using visualization to help yourself do that, ask what questions do you want to answer. If you're, again, trying to make something that's going to be used in operational decision-making, ask yourself what task or decision is the user trying to make. And if you're trying to create an intuitive visualization for communication, ask yourself, what is the message you're trying to get across? So quickly jumping into some resources. We have a link to, and I'll send this out later, but a link to some visualization leaders and thoughts for beginners. Here you can follow people on Twitter, get some names, and it's a link to a blog on what these leaders wish they knew when they first started creating visualizations. The next resource is a free trial of Tableau. You can sign up for a 7-day free trial. The full version is something you have to pay for, but the free trial is available. And if you want to quickly play with the software, create some visualizations with data that you have, I highly recommend signing up for this free trial. I think as someone who was a complete novice going in, it only took a few days of dragging and dropping before I started to get a hang of the software itself. And last is a recent paper on rapidly developing visualizations and dashboards during the peak of COVID in March of 2020. So how do you create visualizations that create situational awareness for hospital or clinical leads? So that paper was authored by a group of us, myself included, and I'll send out a link to that as well. And lastly, Tableau is a very well supported piece of software. So Tableau, the company itself, produces tons of resources and videos to explain how to use their software. And that's available once you create your or sign up for your free trial. But outside of the resources that are behind that Tableau kind of wall, there are also plenty of videos on YouTube that describe how to use Tableau as a beginner. And there's also a community of users that are happy to help out new users. So there's a community that's similar to Yahoo Answers or Stack Overflow, where you can ask a question and somehow there are always people who are willing to answer those questions, who are traversing those blogs and those groups to answer questions for new users. So with that being said, thank you for your time. I will take the last, I think I knew a little early and we have about 20 minutes. I'll take the last 20 minutes or so to answer any questions. And if there aren't enough questions, we can end a little early. But thank you again. And here's my contact info. If you want to get in touch, I'm happy to answer any email or any questions over email. If you just want to connect, feel free to send me an email. All right, so I'll wait a couple minutes for any participants to put in any questions in the Q&A. And if there are no questions, I will assume my presentation was perfect and we can end a little early, but feel free to put in any questions. Okay, so the first question is, how do you use this Tableau software to present Excel data? So that's a really good question. So let me go ahead and reshare my screen. All right, so my screen should be being shared right now. Let me get out of presentation mode and go back to Tableau. So the first question was, how do you connect data that you might have in Excel to the software? This is a great question. You would click this tab up here. It's called Data. And we already have a data source loaded in. But if you wanted to, for example, put in a new data source or put in your first data source, you would click this button up here. And it allows you to connect to all sorts of different files or servers. So we have Microsoft Excel up here. We have a text file if you have a CSV that you want to connect Tableau to. Microsoft Access. We have different types of servers, including Microsoft SQL Server. So you click this button up here, and it'll take you to your local file directory. And you would traverse this file directory and put in whatever file you want Tableau to have access to, and whatever file that houses the data that you want to visualize. Hopefully that answers that first question. Second question, do you have to create summary stats outside of Tableau and then upload it to Tableau to create the figures? So this is another really great question. I guess to take a step back, Tableau has many different software products. Some of their products help prep your data if you need to clean it. Some products help you merge data sets together, basically get your data ready to be inserted into the Tableau visualization software. Personally, I don't use those software options. I like to do my cleaning outside of Tableau, typically using Python, and then upload a clean data sheet to Tableau in that way. Tableau works best with a very clean data sheet, and it works best with row level data. So if we go back to the public data source I shared really quickly here. So let me go back here. So Tableau works best with row level data like you see here. So every row has an index, and every row describes, in this case, a safety event involving a medical device. And Tableau is able to grab a column. Let's look at event type, since that one seems to be pretty simple. It's able to calculate, okay, if there are only, let's say there were only these 19 rows of data are uploaded to Tableau, it's able to calculate that there are, what, 4 or 5 different injuries and 14 different malfunctions. So you don't have to upload the summary of your data. You can upload the raw data that has a row for every sort of data point, and Tableau is able to make those calculations. And you can also put in custom calculations using, it's called a calculated field. So for example, if we wanted to create an age column, which we don't have now, we only have date of birth, we could create a calculated field where we use this date of birth and we subtract it by today's date, and it gets you a date of birth, or sorry, an age column that you would rename age, and that will be a calculated field that you created that has the age of each participant. Hopefully that answers that second question. And third question, how would you view more detailed crosstabs? So for example, race and gender, another good question. So let's open up a new sheet. And in this case, we would look at two different dimensions. Two different dimensions would make up our rows and our columns. So we would grab our sex at birth, put that in our rows, for example, and then we would grab our race column, or our race dimension, put that in our columns. And you can see we're creating this crosstab here. And then to fill in these numbers, we'd grab our number of records and either drop it in text or right on top here, and it will fill in automatically that crosstab of race and sex at birth. And this can be done for any number of dimensions. So if we wanted to look at race and county, for example, we could do that. If we wanted to sort by what county, or I guess city in this case, has the most participants, we could create that crosstab. And these are things that you will pick up at if you decide to start using the software, but we could then go into our analysis and create, for example, our row and column grand totals that tell us, okay, there are 3,500 people in the District of Columbia that are participating in the study, and then here's the breakdown by race. And you can do the same with column totals. So if we go all the way down to our column totals, we can see the number of participants from each race. Okay, so I think I have answered all the questions. I'll leave a couple more minutes just in case there are any new questions, or maybe your question wasn't answered in the way you were expecting. And if there are no new questions, I will say goodbye. And thank you all very much for allowing me the time to present. All right, and again, thank you very much. Here's my contact information. A live recording of this presentation will be sent out along with the links, and I hope you all have a good rest of your day and a good weekend. Thanks again for joining.